Hi everyone, so we're looking at some more multiple choice questions on angles, deal with angles in a triangle, and we're going to look at some with angles with parallel lines and so on, right? So here in this question we have, it says in the figure above, ABC is a triangle in which AD here is equal to BD is equal to, so BD is here, and is equal to CD. Now you see any double lines on the two strokes on each line, that means that those lines are equal to each other, right? We want to know or find the angle ABC. So angle ABC is actually all of this here. Right? So we need to find out what that entire angle is. So if we realize this question, this triangle can be broken up into two smaller triangles. We can break it up into, again, my diagrams are not perfect. We could break it up to this, B, D, E. We could also break it up to this one, B, D, C. Now, if you look at the two triangles, what kind of triangles are they? If you look at the first triangle here, let's call this triangle 1, and this triangle 2, right? In triangle 1, right? It's an isosceles triangle because we have two equal sides, right? Meaning we have two equal angles as well. And this one here, I forgot to put in the angle, 50, they gave us that. We have two equal sides, so we also have two equal angles. So maybe for this second triangle here, I could find this angle at the top here, which is actually this piece here, right? And then I'll need to find the next part after to find the entire angle ABC. Now, so first things first, in this second triangle, the angle at the bottom is 50. Now we know that the two angles are equal to each other. Now, some of you all might say, well, this is 50 as well. This one down here is 50 by D. But no, so a way to look at it is that if you take your hand and if you cover this, if you cover line BD, right, you remain with 50 degrees, right? And then if we cover DC with your hand, so literally cover it, you're going to remain with angle B, right? And those two angles are equal to each other. So this is actually 50 as well, right? Cool. So we have our two angles there. So this piece here is 50 degrees, right? Now we need to find this angle. So how are we going to find this angle? Well, in this triangle, we could also find angle D from here, right? So how would we find angle D? Remember, the three angles in a triangle add up to 180. So you're going to say 50 plus 50, which is 100. And then we're going to say 180, take away 100, which is 80 degrees, right? So this is actually 80 degrees, right? So now I have 80 degrees here, right? And now I could find this angle here. If this is 80, angles on a straight line add up to how much? 180, right? So if this is 80 degrees, then this here had to be 100. You even need to do working for that, right? Cool. And again, so this is 100 here, right? Good. We want to find the angle at the top in triangle 1. Now again, do what I was telling you, right? Cover with your hand AD, right? That is this that's this here, right? And if you cover BD with your hand, that is this piece here, right? So basically these two here and here are equal to each other. So you have to say 180 take away 100, which is 80 degrees, right? And then because those two angles are equal, you have to divide by 2, which is 40 degrees. So here will be 40. Here is also 40. So that means that here is 40. So angle ABC would be 40 plus the 50, which is 90 degrees, which is option D, right? So again, you need to pull out the two triangles separately and work with them. One thing you need to realize, they're both, it is basically two isosceles triangles attached to each other, right? To find out which two angles in isosceles triangles are equal, in an isosceles triangle, they would always tell you which two sides are equal, right? So basically cover one side, one of the equal sides with your hand, right? That remaining angle will be one of the equal angles. Then take the other equal length side, cover it, and then the other remaining angle. That's how you is an easy way to find out which two angles are equal. Because normally people like to say, okay, it's two base angles, right? But you really need to it really coincides with the equal sides, right? Just keep that in mind. So now we have in the figure above, AB, so AB is the line at the top there, and CD are parallel. Which of the following best describes the relation between X and Y? First of all, you need to know what are parallel lines. Parallel lines are two straight lines that never meet, right? Parallel lines are denoted by the little arrow that looks like that, right? Sometimes you'll see it like two arrows like that. Sometimes it'll have one, sometimes it'll have two, right? So it represents parallel lines. Now, this is the easiest rule, I would say, with parallel lines. So for parallel lines, let's see, are you seeing the Z forming here? Let me use a different color to denote this. That should make you a little bit easier for you all to see. So, all right. So are you all seeing the Z? All right, let's hope I can trace it. Y'all seeing the Z there? Right, so the Z, right? Z angles are equal, meaning the two angles in the little corners here are equal to each other. They are also known as, well, they are known as Z angles. So the Z could be a regular Z, sometimes the Z might be wrong side like that. Or the fancy word for it is alternate angles are equal. So basically, in this question, X is equal to Y. Right? So very basic. Right? So either, if you see the Z like this, those two angles in the corner there, little peaks, they're equal to each other, right? Alternate angles are equal, or Z angles are equal. Alright, so on to our next question. In the figure above, not drawn to scale, angle PQR is equal to 40. So that's my 40 right here, right? QR is parallel to PS. So you see well, here was a little faint, right? So QR is parallel to PS, right? You see the little arrows. We want to know the size of angle QPR. So QPR is actually this little thing there, right? So how are we going to figure it out? Well, we just learned something with parallel lines. Are you all seeing the Z here? Let me try and draw it as best as I could. So coming down this way, right. You all seeing the Z? So therefore, if that is 65, this is 65. And now looking at our triangle PQR, what is the rule? The main rule of the triangles? The three angles in the triangle add up to 180. So you add up the two angles you have, 40 plus the 65. Whoops, that should be 65. Let's fix that. Right, 65, which will give me 105. And then to find the missing third angle, you have to say total 180, take away 105. And borrow one from the 8. And that's 75 degrees. So angle QPR is equal to 75 degrees, right? So just one thing to note, so my answer is D, right? One thing to note, they said the size of angle QPR. I would have mentioned this at some point before, but like they didn't really specify or draw which angle, like how I drew in here. Okay, it's this angle here. But really, when they list it like this, QPR, we're really looking at the letter in the middle, P. So it's really that angle there at P, right? Just let's keep that in mind. Hi, so this question says in the figure above, AB is parallel to CD and angle JKB is 125. So JKB is 125, so this is 125 degrees, right? They're right. They said AB is parallel to CD, right? Cool. So there are many ways, different ways to do this question, right? I'm going to show you one way. We're using simple rules. So first rule, if you look at this line here, we know the rule of straight lines. Angles on a straight line add up to what? 180, right? So this is our first piece we're finding out here. So 180, take away 125, and we will get, sorry, that's 7, 555, right? So this here is 55 degrees, right? Now, next part, AB and CD are parallel, right? So you see any Z form in there? Right. So therefore this means here is also 55, right? And now, a rule here, I'm just going to draw this over so you can see it. So this is L here, this is D, this is C, this is G, and we have AB there, right? Supposed to be parallel. So I'm just going to show you angle L here is actually equal to this angle here. Why? Because vertically opposite angles are equal, right? So therefore L would also be 55, right? So vertically, angles are equal. Makes angle MLD, so MLD is 55. Alright, just to go over, first thing we did was notice that angles on a straight line up to 180. So if this is 125 on top here, therefore 180 take away 125 will give me the 55 degrees here. Then we just learn the Z rule, alternate angles. So this is 55 here, and this is 55 here. And in the last rule we just learned is vertically opposite angles are equal, right? Very simple. Alright, so this question are also very simple. AC and DE are straight lines intersecting at B, right? So you have AC and DE, right? Angle DBA is 58, that's what they gave you there. They want us to find angle ABE. So angle ABE, they want us to find this. So this one here is simple. This is a straight line. Angles on a straight line add up to 180. So 180 take away 58 will give us my answer. 7 as 1, 2, 7, 22. Sorry, 122 degrees. So I see. Very simple, right? Just need to know angles on a straight line add up to 180. Cool. Next part. Which of the following angles are equal? So remember what I just showed you? Vertically opposite angles are equal. That means this is equal to this. And I can put X here. X is equal to X here, right? So let's see. DBC is equal. So that's DBC is here. Is equal to CBE. Where is CBE? CBE is here. Those are not equal. Those are in a straight line. So this one off. Next one. CBE, so here is equal to ABE. ABE, that's here. Again, this is not a straight line. So these are not vertically opposite, they're not equal. So let's try ABD. So that's here is equal to CBD. Again, so ABD, they're telling us is equal to CBD. So this is wrong. So it had to be D. Let's just check. ABD here is equal to CBE here. So you see vertically opposite angles are equal. Very simple, right?